Hi, hello. Welcome to the channel. This video is about artificial intelligence, large models hallucination. We will look into what is AI hallucination, what are LLMs, why large models hallucinate, how to fix AI hallucination. AI models process the data and generate response to user queries. For example, a user prompts AI model to show up top 5 entertainment TV channels. The AI model might respond with top 5 entertainment channels which are live or existing or running in the current entertainment industry. This is a good response of AI model. If AI model respond with entertainment channels that are discontinued recently and no longer broadcasted, then the AI response is misleading and hence AI model is hallucinated. Now, let us look into the details of AI model hallucination. AI models present incorrect responses in an authentic and confident tone. These false fabricated responses that appear to be correct are known as AI hallucinations. AI models, especially large language models like LLMs, sometimes produce misleading information to the user queries, that is, user prompts. For example, in healthcare, LLMs are used to personalize patient care. When a doctor asks LLM model for patient's medical records, AI model might provide fabricated records of patients like patient might have already been discharged from hospital, but AI model may show up the response as patient still undergoing treatment. Another example, when user asked to list top 5 restaurants in the city, AI model confidently included restaurants that have been currently not operational or closed. Now let us look at what are LLMs and why LLMs hallucinate. Only LLMs hallucinate or other AI models also hallucinate. AI models can be statistical models, language models, vision models. The language models and vision models can be small models or large models. Small models are trained on small data sets and a fewer number of parameters. Say, if it is a small language model, then the model will mostly support single language pattern. If the model trained with billions of parameters or trillions of parameters, then the model is called large language model. LLMs are characterized by large number of parameters that make them expert in processing, understanding, and generating text. LLMs can predict, interpret, and create human like text, including the syntax and semantics of words. Large language models have new capabilities. LLMs are part of NLP, natural language processing. LLMs can predict the next word based on context. For example, the model can complete the sentence beginning with I want to eat cup followed by a blank. Which word like cake rather than unrelated word like coffee or something else. I want to eat cupcake. Now, what are the applications of small language models and large language models? Small models may respond to user prompts, answer short questions. Small models may be limited to single language. Large models can summarize the text, translate the text, grasp various language structures. For example, GPT-3, Google Gemini, Llama Meta AI. Key identifiers of such as training data size, emergent abilities, architecture separate LLMs from other language models. Other than LLMs, there are large models for vision which are called LVMs, large vision models, generative AI models, multi models which support both text and images. Now next let us see why LLMs hallucinate. LLMs are trained on data collected from internet, Wikipedia, books, articles. This data is rich in quality but with inaccuracies, misinformation. LLMs are trained to predict text without fact checking to find the truth. Hence, LLMs hallucinate. Now, let us look into the cause of LLMs hallucination one by one. First comes the data. LLMs fail to use the available data efficiently due to large volume of data which may include opinions, beliefs and research results. There could be case where there is insufficient data and LLMs insert the missing data and extrapolate the missing data and make the data sufficient to respond to user queries outside the scope of the trained data. Second comes the domain knowledge. If the model has difficulty in processing new terms, say new medical terminology, as humans does guesswork, models also try to guess the meaning of the new medical terms and provide the most probable response to the user. But most probable response may not be true, especially in sensitive fields like healthcare, finance, and law sector. LLMs are also used in legal sector. LLMs can simplify legal jargon into plain language, making policies more accessible. LLMs could predict court case outcomes based on historical data. But if the data and the changes in the law are not frequently updated in model training, then LLMs can hallucinate and confidently provide incorrect outcomes for the court case. The knowledge base need to keep up with the ever-changing regulations. Now, third reason why LLM hallucinate is errors in the workflow. LLMs cannot make out if it is responding from memorized data or from the imagining data to generate a new text causes errors in the LLM workflow. There is a risk that some individuals with malicious intentions use LLMs to create and amplify false information. The model may be overtrained or undertrained, which cause overfitting or underfitting, and model may fail to generalize the response. LLM's generated output might not be true for all use cases. For example, in healthcare sector, the treatment or the meal planner may not be same for all patients with diabetes. In legal sector, the knowledge base must be built based on the differences in national and local laws, and knowledge base must be up to date with the ever-changing regulations. While training a model, all edge case scenarios need to be considered so that model can learn when to generalize and when to be specific. Lastly, user may not give clear perfect prompts to the LLMs. LLMs respond to only clear prompts and may not grasp the context from user's perspective. Now moving on, only large language models hallucinate. How about other AI models, foundational models, small models, statistical models, vision models, with which we saw in previous slides? Do they hallucinate or only LLMs hallucinate? Answer is other AI models also hallucinate. They provide incorrect responses, but the incorrect responses from these models are referred as errors and not hallucinations. Model errors are inaccurate responses to user prompts due to limitations in training data or inaccurate calculations in confidence score. Models hallucinations are due to probabilistic sequence over factual accuracy. For example, generative AI large model go beyond natural language processing tasks and generate images from text to image program. Generative AI models go beyond training data and imagine to generate new images which are out of context, causing hallucination. The goal of all LLM applications in law, finance, and medicine is to minimize inaccuracies and hallucinations by incorporating domain specific knowledge through established knowledge base or through reference documents. So, now we'll see how to fix AI LLMs hallucination. Large models hallucinate can cause profound implications in sensitive fields like finance, healthcare, where accuracy is vital. How to reduce hallucination? First, update the model knowledge base by including domain specific knowledge through external documentation. When there are user queries on new and rapidly changing terms, relevant external documents are retrieved using a retriever module. This improves the model response. Second, reduce hallucinations by tuning the text generation parameters like frequency penalty, presence penalty, top P parameters. Frequency penalty is conservative use of repeated words. Presence penalty is generating new words that have not occurred in the generated text. Top P control response diversity by defining probability threshold for selecting words and customizing the model response range. All these factors reduce risk of hallucination. Control randomness of output of LLM model to reduce hallucination. Third point, fine-tune LLM outputs by immediately choosing the next word with high probability, that is greedy search, or allowing for some exploratory or some exploration by predicting multiple words simultaneously, like beam search. Fourth point is including reasonable models in LLMs so that LLMs verify fact checks user prompts with reasoning at each step before responding. Training LLMs with challenging user prompts. User may not give perfect prompt to the model. The model must be trained to focus on most relevant portion of the user prompt and understand the context. Disclaimers and citations. LLM platform builders, companies, or individuals who develop LLMs like OpenAI, ChatGPT, Google Gemini have included disclaimers. Disclaimers could be something like LLMs can make mistakes, fact check important information. These kind of disclaimers help LLM users. LLM builders also provide citations to LLM users to reduce hallucinations. LLM builders' citations mention the source from which information has been retrieved. Finally, disclaimers and citations provided by LLM platform builders to LLM users, and in turn, LLM users providing feedback on LLM output to LLM builders, which is two-way communication, help build trust and verifiability. For more AI and ML in-depth technical videos, please subscribe to my channel and let me know if you have any questions. So this brings us to end of the video. I hope you like this video. Please like, share and subscribe to the channel. Thank you for watching.